Parabolas, and nonlinear systems. To listen for signals from space, a radio telescope uses a dish in the shape of a parabola to focus and collect the signals in the receiver. While we studied parabolas earlier when we explored quadratics, at the time we didn't discuss them as a conic section. A parabola is the shape resulting from when a plane parallel to the side of the cone intersects the cone. Parabola definition and vocabulary. A parabola with vertex at the origin can be defined by placing a fixed point at f, 0p, called the focus, and drawing a line at y equals negative p, called the directrix. The parabola is the set of all points q, x, y that are an equal distance between the fixed point and the directrix. For general parabolas, the axis of symmetry is the line passing through the foci perpendicular to the directrix. The vertex is the point where the parabola crosses the axis of symmetry. The distance from the vertex to the focus, P, is the focal length. Equations for parabolas with vertex at the origin. From the definition above, we can find an equation of a parabola. We will find it for a parabola with vertex at the origin, C, 0, 0, opening upward with focus at F, 0p, and directrix at y equals negative p. Suppose q, x, y is some point on the parabola. The distance from q to the focus is d, qf equals square root of x minus 0 squared plus y minus p squared equals square root of x squared plus y minus p squared. The distance from the point Q to the directrix is the difference of the y values. D equals y minus negative p equals y plus p. From the definition of the parabola, these distances should be equal. The square root of x squared plus y minus p squared equals y plus p. Square both sides. X squared plus y minus p squared equals y plus p squared. Expand, x squared plus y squared minus 2py plus p squared equals y squared plus 2py plus p squared. Combine like terms, x squared equals 4py. This is the standard conic form of a parabola that opens up or down, vertical axis of symmetry centered at the origin. Note that if we divided by 4p, we would get a more familiar equation for the parabola. Y equals x squared divided by 4p. We can recognize this as a transformation of the parabola y equals x squared, vertically compressed or stretched by 1 divided by 4p. Using a similar process, we can find an equation of a parabola with vertex at the origin opening left or right. The focus will be at P, 0, and the graph will have a horizontal axis of symmetry and a vertical directrix. The standard conic form of its equation will be y squared equals 4px, which we could also write as x equals y squared divided by 4p. For parabolas with vertex not at the origin, we can shift these equations, leading to the equations summarized next. Equation of a parabola with vertex at hk in standard conic form. The standard conic form of an equation of a parabola with vertex at the point hk depends on whether the axis of symmetry is horizontal or vertical. The table below gives the standard equation, vertex, axis of symmetry, directrix, focus, and graph for each. Since you already studied quadratics in some depth earlier, we will primarily explore the new concepts associated with parabolas, particularly the focus. Applications of parabolas. In an earlier section, we learned that ellipses have a special property that a ray emanating from one focus will be reflected back to the other focus, the property that enables the whispering chamber to work. Parabolas also have a special property that any ray emanating from the focus will be reflected parallel to the axis of symmetry. Reflectors and flashlights take advantage of this property to focus the light from the bulb into a collimated beam. The same property can be used in reverse, taking parallel rays of sunlight or radio signals and directing them all to the focus. Nonlinear systems of equations. In many applications, it is necessary to solve for the intersection of two curves. Many of the techniques you may have used before to solve systems of linear equations will work for nonlinear equations as well, particularly substitution. You have already solved some examples of nonlinear systems when you found the intersection of a parabola and line while studying quadratics, and when you found the intersection of a circle and line while studying circles.